Welcome to my talk. I'll be talking about an introduction to Houdini for game VFX pipelines. Quite surprised by how many people chose for this because Houdini is doesn't really have the best reputation among all programs, but I'm happy that you're here. So this is me, the person you sacrificed your last valuable time to in this conference, some nerdy guy going to talk about Houdini. I only graduated university last year, but I noticed one thing out of everything I learned there, and that's that Houdini is definitely something of a passion for me, and that I want to continue increasing the amount that Houdini is being used in the industry. And I definitely think that there is a lot of use for it already, which right now isn't being used or exploited the way it could be. So I like to give a bit of an overview before a presentation, so we're not all just listening aimlessly, talking for like 45 minutes. So what I'm going to do this presentation will be, oh no, that's not supposed to be the case. Okay. So first, the first part of this presentation will be me trying to convince you of why and when we could use Houdini right now in the games industry. After that, I'll specifically talk about Houdini using it in real time, because everyone knows Houdini is already being used a lot in film industry, and the games industry is still trying to grow with Houdini, but it's definitely known as a more cinematic program. So after that, I'll also give you a very specific example that I made for this presentation, and I'll show you the workflow for it without going too much in depth, of course. And then just as a fun little way to end it, I'll just give away some useful notes, some cool techniques you can do that really just would be great if you actually want to start using Houdini and maybe like you want to create something quickly and see what can I do with this program and just see how easy it is. So let's start with why and when to use Houdini. The first thing would be, well, something that most people know because it's kind of like the tagline of side effects, it's procedural, right? And non-destructive workflow. This is something that in my opinion, we can really start thinking about in the games industry, because as larger games get made, the worlds start to get a lot larger, but a lot of the geometry that we make starts getting a bit repetitive sometimes. So there's lots of games that right now are out there, such as mostly battle royale games like Fortnite. Well, a lot of the materials, a lot of the houses are actually copied from one place to another, and you'll find the same kind of layout everywhere. Well, with Houdini, we can avoid that really easily without a lot of extra work. So just to show something, this is like a banner of the Houdini website that I stole, and I was like, let me just try to recreate it in a procedural and non-destructive way and see how quickly you can do this. Just a couple of notes like this. I start by creating the main shape, then I remesh it to create a uniform amount of polygons everywhere. And then there's this little option by dividing it and having this compute duals, which you don't have to remember at all, but it just creates this beehive-like pattern. And then I just extrude with a lot of like randomness on each polygon, and that's basically it. I tried to see, well, did I mess up anywhere? Is it still procedural? I just feed in another part of geometry, such as a sphere, and it works. And Houdini's favorite test geometry, which is this rubber toy, also works. Now, the detail on this gets a bit lost because my divide is a bit too big. So I just change some parameters and perfect. You can even see that there's the UV texture on the first one, a standard UV texture because it's unwrapped, and it even carries over to the new one without destroying it. You can barely see it, but you can see the grid-like texture on the second version. Then the next thing you use Houdini for are tools. So let me just take a drink, because yeah. So tools are something that we can create very easily with Houdini, which is also one of the reasons why I think Houdini could really be exploited more, since right now we're stuck with a lot of tools and in-house tools that are made by coders, programmers, and it's really hard for an artist sometimes to, well, completely get to learn to use these tools. Whilst if we create tools with Houdini, it's quite easy to use in-engine. So an example of this would be for VFX-wise. something that Andreas Glad made. I'll be referencing some people, and I put all their names below the pictures. So he made this little tool that you can use inside of Unreal to create this specific shape, which you can, because it's inside of Unreal, you can play the animation, put down the points where you want the spline to be, to match the animation perfectly, and then generate a mesh without ever leaving Unreal. And this would be a great mesh to use as like a VFX swipe or something like that. Then optimization. This is something very big that is honestly extremely useful in Houdini, because we can all do it in the same package without having to go somewhere else. An example here by Simon Verstraete is we have a high poly and a low poly next to it, and he's going to generate a game model version of the high poly, because this low poly is a bit too low poly, right? Like if you would use that and then bake normals, it's still not going to look great. So normally you'd have to manually remesh it, but it's going to take a while. So instead here we have a technique where he gets the edges of the low poly based on the angle, and then he converts that selection to an attribute on the high poly, which, as you can see, try to use a pointer, as you can see, selects all of these edges more like a gradient. And then he reduces his mesh with one node, and he uses that attribute to decide where I reduce the most. Because these edges are the most important part in a game model. In the flat parts, we can bake normals easily, and a player will never see it. But on the edges, of course, you're going to see that the illusion fades. Well, here, with this method, you automatically keep most details around the edges and reduce all the details where they're not needed. So the next part will be to talk about Houdini in game uses specifically, right? So there's a couple of ways to get something like those cinematic VFX you see made in Houdini, to get them into an engine. The first one are specifically made for RBD simulations, and that is to convert a destruction like this, which I made just groundbreaking, and I convert that to a skeletal mesh animation to use in my VFX. So the way this is done, I don't have to really think about exporting. It's very easy. There's just one node which automatically converts a rigid body simulation to a skeletal mesh with the animations baked on the keys. It's not very intensive at all. I wish I would have tested a bit more, but I've copied them all around and I've used them lots of times, and you can't really see it pop up too much. The amount of joints is quite all right, as long as the geometry that the joints are affecting isn't too high res, right? Because of course, the more resolution you'll have on those, the more performance will be impacted. But this, in general, is a very performant way to get your destruction simulations into Houdini, into Unreal. Another one would be vertex animations. Now this one can do both the same and a lot more. It's very flexible. So as you can see here, there's a couple of them. The first one, dynamic remeshing. I'm going to go more in depth about that one, so let's just go to the other ones quickly. Particle sprites. Houdini is great with particle simulations, and you can directly convert them from Houdini sprites to Unreal Engine Niagara sprites. The same with, again, rigid body simulation. Instead of converting it to a skeletal mesh, if it's more appropriate, you can also convert it to a shader, a vertex animation shader. So if you want to avoid using skeletal animation for some reason. And soft body dynamics, very useful as well, because you wouldn't be able to do that with joints, right? It would be an insane amount of joints, not very performant at all, but with one shader, we can animate this cloth breaking and so on. But the difference between this one and the first one, which is the fluid sim, is that the cloth still has consistent geometry, right? The amount of polygons, they don't change. Well, with the first one, they do. So how would we get that into our engine? Well, this is what it looks like in Houdini. I just took the test geometry and I made it kind of flat and fall like a fluid sim. And then in Unreal, it just looks like this. Now, how is this done with vertex animation? It's pretty easy. So this is the shader complexity you can see in Unreal. It's very low, surprisingly. The asset size is pretty small and it's very flexible. So this is what it looks like. So the model of our rubber toy is on the left. The reason why it's laid out like this, well, Houdini automatically does this for you when you try to export it as a vertex animation for engine. It'll automatically place all the polygons in a grid system because we're going to need different amount of polygons each frame, right? So we don't really have a starting frame, we just have them all laid out. And then the shader, which are textures on the right, these vertex animation textures, they feed into the world position offset and they take all polygons, place them exactly the way the toy should look each frame. Funny thing, actually, someone from SDC checked my slides before this, and they thought those images were corrupted, but they're not. That's what they're supposed to look like. So yeah, the one note here, though, is texture budget, right? So you do have to think about that, and the more polygons you need, the more high-res you want your texture to be as well. So you do have to be a bit careful with that, but for most cases, it's going to be all right. Then another way to get this Houdini magic into Unreal or Unity for that matter would be by using data interfaces. So one of them being point cache, we can convert our point, particle simulations, smoke simulations, anything to particle data and just store all the positions, all attributes, velocity, color, everything into a JSON file. Just a text file basically. We import it into Unreal and Niagara can read it and place the Niagara particles exactly how you made the simulation into Houdini, right? So this is a fireworks simulation in Houdini. And then I decided, let's try to just convert this one by using a JSON file into Niagara. And this is what it looks like in Unreal, right? It's a perfect one-to-one copy. And it just reads all the data from a JSON file, which is extremely low in data, of course. It's just a couple of kilobytes, and I can even add custom attributes to this. Like I can have some of them, I guess, have a custom attribute, yes or no, and then those are the ones that explode or whatever like that. You can do lots of things. The good thing about this is, well, we have a pre-made simulation in Houdini, but in a game something else might happen with the simulation. Particles might get affected by some other force. Well, with this, we're not stuck on this. We can always just add forces onto it using Niagara. We still read from our original data, but we can do additive simulations in real time onto it. So now I will go over a specific example I made for this talk. So I decided to make something I thought of a while ago because it's something just I find cool, nothing else. I just find it cool in games when we have magical bridges that build themselves when the player walks over them. You do see them now and then. So I decided, let me try to make it in a procedural way that allows us to make as many of those as we want in as many shapes as we want without having to every single time make the exact thing, the exact simulation or animation by hand. So this is what it will look like. Yeah. So this way we can have, with the way I made it, instead of making this custom in, for example, another 3D software, I made it procedural with Houdini and made a tool out of it for Unreal. So the way this works is by basing everything on the one spline. I want the artist to just define where the bridge goes, and they have all the settings to customize the look of the bridge, but the only information I need to create this animation is this one spline. So I resample this spline in Houdini just so it has a uniform amount of points. This spline is made by the artist in Unreal in real time. And then I copy, well, this is just to build the bridge. You could do anything really. I just made quickly out of cubes with some randomization on the scale. And then here the simulation part comes. Well, how did I base that on the spline? I thought of, well, since it's a bridge constructing, I thought of destroying it and reversing the animation based on where the player is. So first I make this destruction animation, and I don't want all of the blocks to just immediately start simulating by gravity. So I thought, let me make a group, and basically as this group grows, right, I activate those blocks that are in the group. And then I also create this collision geometry with some randomization that'll go over the spline. It's pretty creepy. And combining that, as you can see, we create a quick simulation, all based on the same spline. And then by reversing it, we have a quick construction simulation, and the only thing we've used is a couple of nodes, nothing much more than that. And then I noticed, okay, so we can do this with any spline. I tested a lot. Of course, once I tested, I saw, oh, there are some problems with my nodes, like sometimes the group wasn't big enough, so I adjusted the way it's calculated how big I want my collision geometry to be and everything like that. But now it works with every spline, and we can create as much as we want, any shape, or even, because I exposed some of the other parameters as well, like twists and stuff. Or this actually looks more like rail tracks, for example, if I just only use two columns of the bridge and put a big enough gap between them. And the twist is this, what I was talking about, kind of looks like DNA. This option was just in there when I placed blocks on splines in Houdini. So I decided to expose it to the user so they could create something like this. And we can, instead of reverting it, we can just destroy it like this. Or, of course, not in there. Or, of course, build it again. I think it'll happen at the end. Oh, there was a side jump. Yeah, okay. So, or you could create something like this, right? All with the same tool without having to go into Houdini at all, right? This is made in Houdini, but I expose it to Unreal. So the last part of this presentation, I thought I'd end it by just adding some useful, cool stuff that you could do in Houdini. One of the first things I found like this, which has left an impact on me, was something like this. I, again, put the name of the YouTube channel I found it on below. That's Ricardo Ponce. I probably butchered his name, but it's a pretty cool type of simulation that I've used a couple of times also to create real-time VFX. And it's basically an algorithm that is used to create some kind of branches growing. And you can use this almost anywhere with just a couple of nodes. So it's called the find shortest path. And basically what it does, it does something like this, right? You could do it on some geometry or any shape you want. It doesn't matter what the geometry is, but we basically create a little simulation that finds the shortest path from some random points to other points, which creates something like this. You could, of course, get that into Unreal with vertex animation, because it's dynamic geometry. The next thing I thought is really just changed everything, because I never have to think about it again, is the make loop node. I think it's made specifically for game artists. Well, any kind of animation, simulation, smoke as well, anything that's based on particles will work. If I make it loop with the Houdini make loop node, it just fixes everything for you, right? This technique is used a lot manually as well, by like doubling the timeline length, reversing it, merging it with the original, something like that. But now this is all in there, it's just one node, and I use it a lot, really. You can use it with, as you can see, Pyro Sims. But yeah, it will really fix everything for you. Then another thing is L systems. So L systems is something specific to Houdini, something you don't really find in other programs. It's a basic math algorithm that was found by someone years ago, right? And Houdini decided to put it in a node in their program, and you can create some really cool things with it by creating some basic rules. So L systems work by iterating over those rules over and over again. And this math algorithm was designed to kind of represent how plants grow in nature by using math. So by using it here with some quick rules, you can create any kind of natural growing simulation without just scaling it up. It's actually iterating over the rules and growing. And another thing, which is very interesting for environment artists probably, something that I've used before as well, when you want to, for example, create a big fencing area or something on an environment that's not flat, and you don't want to manually place a spline or have to move things up and down over the mountains, there's this little ray node which will trace in any direction you want, and then place the geometry on the first collision. So it will automatically lay it out on environments, for example. And if you have a fence that is attached to this spline, it'll automatically perfectly lay out on this environment. You could use it for lots of other things as well. So that was my presentation. Thank you for coming and listening. If there are any questions that I can answer, yeah. No. So I haven't, and actually someone, because I was doing this talk and I talked with some other people from the VFX team, someone actually yesterday mentioned that Blender is doing this as well. I think my main take about it is that it's great, honestly. Anything node-based sparks my interest. But the good thing about, I guess, Houdini nodes are that you have it all in one package, right? Blender as well is focusing on this as well. But Houdini has geometry nodes, which is one part of Houdini, but also everything from simulation-based stuff, shader-based stuff, it's all based on nodes. You can all take information from the geometry nodes to the shader nodes based on that. So it's basically this whole system that is all made out of nodes. And I think if you have Googled Houdini before, you probably hear a tutorial and he starts talking about DOP systems, SOP systems, FOP systems. I avoided them for now, not because I wanted to make it easy for you guys, but because I don't remember them either. But they basically really allow you to do anything more than geometry, all based on nodes, and do that in the same package, which is really useful. But I think Blender is doing a great job anyways with that geometry node stuff. Yeah. Have you tried the live link? Yes, so pretty interesting here is with the live link, you can be editing your digital asset, right, from in Houdini, adding nodes, and it's a live session to your game engine. So with Unreal, you can actually see what changes. So that way you can be working in your 3D software and the engine at the same time, and the geometry will get updated, right? And I have used it before. For VFX, it's not that useful as it is for environment art, I think. Also for VFX, Houdini can only live link with one frame, right? You can't really live link a simulation or anything like that. So, but it's a very cool tool for anything environment art-wise or character art animation as well. Yeah. Yeah. So the problem with that is that Houdini is, I think, working on being able to export the whole simulation. But indeed, with this one, I noticed, and there are some people that seemingly have programmed it themselves by editing the plugin, but for now, what you will have to do, which is what I did, I create a spline and you see the bridge building in Houdini, in Unreal, but just I couldn't like bake and get the simulation in there working instantly. I would have to open Houdini, press export, and then put it in Unreal, and then it works. Which is a bit annoying, but they are working on that, so very interesting. Yeah. 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 Yes. So that is a perfect example actually, because that one is only one frame, only one static mesh needed, and Houdini can perfectly generate that. If you don't even have to go into Houdini and export. If you've made the process, the node structure, you can convert that to a Houdini digital asset, which is something you put into Unreal, and Unreal basically uses that and it goes through all the original nodes. It does the exact same thing as you made it in Houdini. So you can take your mesh from your content browser in Unreal, feed it to the Houdini digital asset, and it'll create a preview for you. So it'll go through all the nodes, do it. And if you're happy with it, you can bake to static mesh, and it'll bake it to a static mesh in your content browser again, the result. So yeah, you can do that. Yeah. Yeah. Yeah, so that's a bit difficult to say when it comes to, of course, what kind of data was being generated there. But what I usually do with any kind of simulation stuff or any kind of particle stuff, I create a version, a proxy version, right, with lower geometry detail, and I use that whilst building the simulation. So it's very easy because Houdini has built-in options for this. But even with particle sims, you can just reduce the amount of particles since it's one parameter. And at the end, all the way at the end, I increase the amount or whatever I want. I simulate it once and then put it in Unreal. Now, when it comes to the Unreal performance, I haven't had issues with performance that I wouldn't have otherwise. Of course, I've copied around lots of vertex animations and see what happens to my frame time, but I would have to have a full game and put it in there to test, which I currently didn't. So very interesting, but once it's exported out of Houdini, I don't see much of a difference with other programs. But ah, yeah, I see. Well, that's interesting then, because there might have been something in the Houdini code that was having an issue then in the node structure, right? So I have had issues with this with smoke simulations and stuff, but in my experience, it's been incredibly fast compared to which the other programs I've used for this, which is Maya. Um, but of course, I can imagine, depending on what's done, that you had some kind of issue. But yeah, I haven't had this myself yet. Um, it's a bit difficult because I can't look over what you guys were trying to do, but there probably would have been a way to optimize this during construction. Yeah, yeah, the node structure, something in there might have been a bit, I don't know. So Houdini themselves on every node, if you hold middle mouse click, it actually shows you the frame time it takes to calculate, so the MS. So this is an interesting tool that I use sometimes when something's taking long. Also very useful whenever I do something and Houdini is having to wait a bit, I can't do it in real time. On the bottom left, it shows exactly what it's doing. It'll say this node, right? Building this, frame 0.125 out of 1, and then it'll go up and show this node. So I do use it sometimes. But mostly the frame time is what I usually look at. Yeah. 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 So for environment, it's a bit difficult to me to think about, but I can talk about this from a VFX standpoint. One of the things I showed was a fireworks simulation. So that one I didn't use I used the original data from particles and put them into Niagara. If I then use Niagara, other wind simulations or anything else, any other data, it gets it gets added on top of the original position data that I have. So that works. I could I didn't have the time to do it for this one, but I could, instead of using this rigid body simulation for the bridge, I could convert each block to a point and just export that to Niagara, and then place mesh particles on those points and have the exact same result. And then I could test stuff like adding forces on top and other things, and that would work. Yeah. 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 Because I'm not a master either, for sure. Not at all. For me, it helps that I'm passionate about it, right? And I can easily get lost in it. But I'd say it takes a while because most skills aren't transferable from other software. I feel like if you would enjoy something like blueprinting and materials in Unreal or anything else node-based, you probably have an easier time picking up Houdini, right? Um, I would say, depending on what you're aiming to create, but if you're aiming to create something procedural, like a procedural wall or bridge, building, stuff like that, I think you can get, I mean, you can of course follow a tutorial and do it very quickly, but to do it all on your own, it would probably take 1 to 2 months to get a grasp, and then you've only done the procedural building part, right? You still have to, of course, learn the whole stuff, but it's the main thing. You can save time by modeling stuff in other, if you like modeling, because like doing it yourself manually in Maya or something, you can do that. You can model your building blocks that you are going to build your house out of, for example, your procedural stuff. You can model parts of that, put them into Houdini, and only use Houdini, right, to do the placement, right? And I think that's probably one of the best ways to use Houdini right now, since modeling in Houdini, I like it a lot, but I know most people don't. So, but it would take a fair amount of time. That is true, and that's a bit of a problem, right? Or yeah, that is the main problem. So the main thing right now, I think, is, as I said it before, that worlds are getting so big that you start seeing repetition in games, in big open world games. And I think that's why it's worth it to explore Houdini, because you put some extra initial practice into it and some extra initial work to make the same thing which you can do in another program. You can now make an infinite versions of it with a couple of parameters changes. And that's where I think the strength lies and why it's worth it to put the time in. Documentation it's all right. I don't think it's that bad, but my main problem that I have with it is the amount of terms that are, they don't make it user-friendly. I said it before, the pop, fop, dop, it's kind of stupid, right, to do it this way. But luckily, one very good thing that I've noticed are the Houdini video tutorials. So they have so many of them that are made by Houdini specialists. And one of them actually got released 12 a.m. last night, which is specifically for real-time FX. So there's this whole ability system, this whole ability mate that I saw it this morning, right? And they uploaded a video of it. It's a couple of videos long, all the different parts, how to do it. That part, I think, is definitely where to look. Just the Houdini tutorials, the video tutorials on the Houdini website themselves. They have a very good selection of them. Yeah. So, okay. Yeah. Yeah. Um, so Houdini FX is needed for the pyro simulations and all of that. So from a VFX standpoint, I'd say FX, but that's the most expensive one as well, I think. It has the most stuff. For anything environment art, procedural modeling, anything like that, you don't need FX. Then you would be using Houdini Core. And I think the price difference in that is quite big. So Houdini Core would be the way to go there. For VFX, anything like that, which is mostly what I showed today because I'm a VFX artist, right? But for anything like that, you would need Houdini FX. Oh, yeah. Okay, so the main thing with Niagara is if you want very specific movement or something like that, you're going to make custom modules, which is great, and I love to do that as well. But it's particle simulation stuff in Houdini is way more like you would do it in Maya, in anything like, of course it's node-based, but you can create very large amount of particle simulations, very direct control. It's a bit more difficult to do directly in Niagara. The same amount of control you have in your original 3D software, right? So stuff such as if you want to, for example, do a rigid body destruction. So I have that destruction, but I want smoke to appear where this destruction happens. But because I'm in Houdini, I still have the original original data from the destruction, and I can use the positions of impact and stuff like that to place particles and emit particles from. Something you would be a bit hard to do in Niagara directly, although you do have impact places, right? Impact events. It's I prefer to do it in Houdini that way. Yeah. Yeah, so that is one thing that actually is being used a lot. Or for example, using your level like that, and instead of exporting it as one big thing, we slice it up in parts, right? I personally think it's a pretty good way to do it. You could also even export the data of where you have the meshes as points and import that into Unreal and read from that and place your static meshes on those points based on the point data, right? Um, but yeah, that is being done a lot, where we just do what you would do in a Unreal script or Blueprint script, right? We can do that in Houdini and export that before putting it in real time. Yeah. Yeah. Well, when exporting particles, there's no model needed. So with that one, it just exports a JSON file, right, with text which Niagara reads. With the vertex animation stuff, right, if you actually need a model, then it generates it for you, and together with the textures. Yeah. Yeah, so that's very limited. Houdini shaders or shops, yeah, are something I haven't really focused on because I'm more interested in the real-time aspect, and you can make them in Houdini and export to Unreal. There's support for that, right? But I like to create my geometry in Houdini, uh, then put it into Unreal and make my shader from there, since the look will always be a bit different, right? I think making the shaders in Houdini is something that is more useful to the film industry, since that's where you'll be rendering directly. Like you're not going to be, well, actually, they're starting to use Unreal too, right? But you want to know what it'll look like in your engine. So that's why I don't feel like it's super useful for us to really put a lot of work into the shader in Houdini, if that makes sense. Yeah. Yeah, so I don't know all of them that they have. They have mantra and karma and stuff like that. But yeah, Houdini does work the same way as other third-party renders included. That it? Then I wish you all a great rest of SDC.